Okay, this is exam 2 for Physics 101, fall 2018. Just remember, I want you to always write your name up here because I hand these back and they're very important for you to study for your final exam. On this question, you're supposed to answer A or B or C or whatever you had. That denoted the version. You kick a ball at an angle of 60 degrees from the horizontal with a speed of 32 meters per second, top of the trajectory. What is the speed of the ball? Okay, well, I'm going to draw a picture just so I remind myself what kind of situation I'm in. I'm looking at this type of situation where I have a ball that begins and ends at the same horizontal level, and then I want to know what is the speed of the ball up here. Now remember, the speed of the ball up here is only in the x direction. And also remember that the x component of the velocity doesn't change, that it's always the same, that it's only the y component of the velocity that changes. This is because ax is equal to 0. And so vx is equal to v naught x, which is equal to v naught times the cosine of theta. And v naught is 32 meters per second times the cosine of 60 degrees. And so that's 16 meters per second. So E is the right answer for number 2. Number 3, same problem. What is the horizontal range of the ball? So I'm looking for this distance. Now, I know that the horizontal range is equal to v naught x times t. So I already know v naught x, that's equal to 16 meters per second times t, but I need to find the time. And so in order to do that, I'm going to find the time up here, t top, and I know that up there that vy is equal to v naught y plus ay times t. This is 0 equals v naught y, which is 32 times the sine of 60 degrees, that's the y component of the velocity, minus 10 times t top. And I can solve that for t top. 32 times sine of 60 is 28 minus 10 t top. That's all equal to 0. If I solve that for t top, it's equal to 2.8 seconds. Now that is not the time that I put in here. To find that time, I do twice t top, which is 5.6 seconds, and that's the time here. I have 2.8 seconds here, 5.6 seconds here. So this is going to be 16 meters per second times 5.6 seconds. What is that? Is that the 88, I think? Let's see, the answer is A. Looks like I rounded off a little bit differently somewhere along the way, and so the answer comes out different. Because when I do this, I get 89.6 or 90 meters. I'll go back and adjust that. I might change it to 90, so that's number 3. Alright, number 4, a rocket is fired horizontally off a cliff that is 200 meters high, has an initial speed of 45 meters per second. After 2 seconds, it hits a helicopter. What is the speed of the rocket when it hits the helicopter? Okay, so let's have a rocket. It's fired horizontally off a cliff, but it doesn't hit the ground. Instead, there's a helicopter right here. It's a helicopter. And I want to know what is the speed when it hits that helicopter. Now, I tell you that t is equal to 2 seconds right here. So at the time that it hits the helicopter, the speed has 2 components, or the velocity has 2 components. It has a component in that direction and a component in that direction. And so I want to find what is the net vector of that. So I'm going to do the vector addition of those 2 vectors. I know that this x component is 45 meters per second. Vx is 45, because that's what the initial velocity in the x direction was. Now I need to also find Vy. It's going to be equal to V naught y plus Ay times t. That's 0 minus 10 meters per second squared, that's g. Or the acceleration due to gravity is negative 10. It's not g, it's a sub g. Times 2. So Vy is equal to minus 20 meters per second. That's a squared, that's 2 seconds. So I have a vectors, 45 in this direction, 20 in this direction. I want to know what is that vector. So I do the square root of 45 squared plus 20 squared. And I get 49.2, or 49 meters per second. So 4 is A. All right, that's a tough first page. Oh, we have one more. I have a brick that's thrown from the top of the building at an angle of 20 degrees to the horizontal. This was and it has an initial speed of 2.5 meters per second. The brick can flight for 3 seconds. How tall is the building? So I have this situation, which is one that you did in lab, and one that if I didn't give you the time, you'd have to use the quadratic formula to find the time. But in this case, I give you the time, so it makes it a lot easier. 3.0 seconds. V naught is 2.5 meters per second. And theta is 20 degrees. I want to know how tall is the building. I want to know y. I know that y is equal to V naught yt plus 1/2 ayt squared, and that's really all that I have to do. I put in the y component, that's 2.5 meters per second, times the sine of 20, times t, which is 3 seconds, minus 5 meters per second squared. That's these two together, half of negative 10, times 3 squared. And so what I get is, let's see, 2.5 1 minus 5 times 9, which is 45. Sorry about that, I made a mistake here. This isn't 1, this is actually 2.6 minus 45, and I get minus 42. That means that this height is 42 meters. It's negative because this is 0, this is minus 42. So E is the right answer for number 5. Hit a ball horizontally from the top of a cliff that's 20 meters tall. The ball's initial velocity. What is the horizontal range of the ball? Okay, so this looks like this. I have 20 meters here. I know that this V naught is equal to 5 meters per second. What I need to do first is find the time. How long does it take the object to drop that 20 meters? So I say y is equal to V naught t. V naught yt plus 1/2 ayt squared. I know that V naught y is equal to 0 in this case, so I have minus 20 equals minus 5 t squared. So t is equal to 2 seconds. So it takes 2 seconds to go from here out to here. To find x, I say V naught x times t, that's 5 meters per second, times 2 seconds, which is 10 meters, so 6 is A. Whew, some tough problems to start out with. Now let's do some conceptual questions. A soccer ball is kicked with an initial speed at an angle of theta. Which of the following statements is true? The initial horizontal component is equal to the final horizontal component. Alright, that's true. Alright, I'm dealing with a situation where following a path like this, that's saying that this velocity is equal to that velocity. And I know actually that Vx is the same. The acceleration is 0 at the top of the soccer ball's trajectory. That's not true. The acceleration is always equal to minus 10 meters per second squared in the y direction. Now if it said that the x acceleration is 0, that would be true, but that's not what it says. The horizontal component of the velocity is maximum at the top of the soccer ball's trajectory. No. The horizontal velocity is the same here, here, and here, and all throughout, so not true. The initial horizontal component of the velocity is equal to the initial vertical component of the velocity. Maybe, but not necessarily. So the answer here is 1 only. D is right for 7. You're in a plane and want to drop a relief package. People below. When do you release the package? All right, well, here's the people. Here's the plane. If you want to drop a package, you better drop it right here, because the package will follow a path just like that. And in fact, when the package reaches the people, the plane will be right here. The car is being pulled along a horizontal track by an external force and accelerating. A cannon on the cart fires straight upwards as its fire would have in the ball. The ball falls behind the cart. Remember, we had this in a concept test. If it's accelerating and it fires a ball upwards, as it accelerates, it moves in front of the ball, and the ball will actually fall right here. Because the ball has a lower Vx. It has the Vx of the cart up here, but now the cart has a bigger Vx here. Which of these plots represents the graph of x position versus time for an object launched from ground at an angle and returns to the same y position? Alright, and it moves from left to right. That's kind of important. This is my situation. I know that the Vx is always constant, and in this case it's also positive. So since the velocity does not change, and since it's positive, C is the right answer. If it were negative, by the way, B would be the right answer. The same height and same time, one ball is dropped and another is fired. Which one will hit the ground first? They both hit the ground at the same time. We did that demo in class. Which of these statements is true for an object in projectile motion? The x component of the acceleration is 0. Yep, that's true. The y component of the velocity is 0. Yep, that's true. The magnitude of the x velocity is greatest at the beginning. No, it's always the same. And the acceleration in the y direction at the top of the trajectory is 0. No, it's equal to -10. So just 1 and 2. Two objects are in free fall. Mass number 1 experiences a gravitational force of 20 newtons. Mass number 2 experiences a gravitational force of 30 newtons. Which one has the larger acceleration? Both have the same acceleration. All right, there's my 20 Newton, which by the way is a 2 kilogram mass, and here's my 3 kilogram mass. This one does feel a 20 Newton force, and this one does feel a bigger force, a 30 Newton force. So why doesn't the 30 Newton force accelerate more quickly? Well, the acceleration is F over m, so it's 30 divided by 3, which is 10, or 20 divided by 2, which is 10. So the answer there is C for 13. 2,000 kilogram car sitting at rest in a parking lot. A bike and rider with a total mass of 60 kilograms are traveling along a road at 10 kilometers per hour. Which has more inertia? I think this was a tutor question, actually. The car has more inertia because it has a greater force. No, it doesn't have anything to do with force. Inertia doesn't. Or nor does it have anything to do with acceleration. Nor does it have anything to do with speed. It only has to do with mass. So D is the right answer. You push an object of mass m with a force F and cause the object to travel distance x in a certain time. If you apply twice the force, what distance does it travel in the same time? I think this was also a tutor question. F is equal to ma. If I double the force, I double the acceleration if I keep the mass constant. And x is equal to v naught t plus 1/2 at squared. I'm assuming that my v naught is 0, and I'll actually put that in the question. I assume that v naught is 0, and if I double my acceleration, then I double my distance. So A is the right answer for 15. The inertia of a body tends to cause the body to resist any change in its motion. That is the first law. An object is moving at constant velocity. Which statement is always true? There's only one force acting on the object. Not necessarily. The net force on the object is 0. Necessarily true, because if the net force wasn't 0, it would be moving at a constant acceleration. There are no forces, or there must be more than one force. Neither of those is necessarily true. Alright, an object slides down an inclined plane as in this figure. A frictional force acts upon the block. Which of these statements is true? The frictional force is up the inclined plane. Yes. Fk is up the inclined plane. The frictional force depends on the mass of the object. Yes, because the frictional force depends upon the normal force, which is affected by the gravitational force, which of course is affected by the weight and the mass. If theta increases, the frictional force will always decrease. Yes, because if theta goes up, Hold on just a second. Okay, I'm going to reword this question just a little bit because it's kind of an important idea. If it's if theta goes up, the normal force will go down. And if the normal force goes down, that means that the kinetic friction will also go down. So number 3 is true, but only as long as the object is sliding. Because if I have an object that's not sliding, I have an object that's sitting there with a static frictional force. In this case, the static frictional force is just enough to hold the thing in place. But if I increase theta and the object continues to stay static, then the static frictional force has to increase because I have a greater component of the weight acting down the inclined plane. So this third statement is only true if the object is sliding down the inclined plane. If the object is just sitting on the inclined plane and then I begin to lift the inclined plane up so that the angle increases, then the static frictional force will increase in order to keep the object in place. I'll reword this just to make sure that that's clear, but I just want to make sure that you're clear with that. The frictional force is dependent on the speed of the object. That is not true. So 1, 2, and 3 are the right answers. 500 kilogram block is suspended by a rope in an elevator. It's descending at 2 meters per second squared. What is the tension in the rope? Look, I know the weight of this thing is 5,000 newtons. Right? Force weight equals mg. So, and I know it's descending, so I know that the tension is going to be less than the weight. I'll work this out in just a minute, but I can then get rid of this and this. I can say that those are not valid answers because those are at 5,000 or more. And so I can probably actually then just say, well, it's probably going to be E because, well, let me just show you. So I have this 500 kilogram block. It has a tension that's holding it up, and it has a weight. And it's descending with an acceleration equal to negative 2 meters per second squared. So Ft minus Fw is equal to ma. Ft is what I'm looking for. Oops. Ft is equal to Fw, which is 5,000, plus 500 times negative 2. So that's equal to 4,000. You hold a 2 kilogram mass stationary against a wall by pushing horizontally. The coefficient is there. What force is required to hold the block in place? Well, the force that's required to hold the block in place is my static friction, and it has to equal to the weight. So the static frictional force must equal to the weight, which is going to be 2 kilograms times 10 meters per second squared, or 20 newtons. So I know that my static frictional force has to be equal to 20 newtons, but I also know that my static frictional force is equal to mu s times the normal force. And notice this is my normal force. So this is 20 newtons equals 0.1 times F. And so F has to equal to 200 newtons. So number 20 is E. You apply a force of 140 newtons to a 20 kilogram mass and it accelerates at a rate of 5 meters per second squared. What is the coefficient of kinetic friction? Look, if I applied this force, I should get an acceleration of 7 meters per second squared, right? F over m. But I don't. So let's draw it. I have 140. Since I don't get quite that acceleration, that means I have a force that's holding it back. And that's going to be my kinetic friction. And I know this is 20 kilograms. I do the sum of the forces equals ma. 140 minus Fk is equal to 20 times the acceleration, which is 5. And so Fk is equal to 40 newtons. All right, now I need to find out what is mu k. My normal force in this case is equal to the weight, so it's 40 equals mu k times 200 newtons. So it's 40 over 200, which is 0.2. B is the right answer. 60 kilogram swimmer pushes on a pool wall and accelerates at 4 meters per second squared. The friction experienced by the swimmer is 100 newtons. What is the magnitude of the force the swimmer applies to the wall? Hold on. Okay, sorry about that. I had a student come see me. I'm just going to start over in 22. 60 kilogram swimmer pushes on the pool wall and accelerates at 4 meters per second squared. The friction experienced by the swimmer is 100 newtons. What is the magnitude of the force? I think this was this a, yeah, this was a tutor question. So I have a 100 Newton force in this direction, 60 kilograms. I have some other force in this direction. I don't know what it is, but I know that she accelerates at 4 meters per second squared. So again, F minus 100, sum of the forces, equals 60 kilograms times 4. So F is equal to 140 newtons, solving that for F. No, I'm sorry. F is equal to 340 newtons, because I take the 100 over here, it's 340. What is the tension in the rope on the left? So we've worked through this problem several times. I'm just going to dispense with some of the initial things and say that FTL is equal to FTR, that these two forces here and here are equal, so I'll just call them FT. All right, and then I know I also have the weight here. I know that this angle is 60 degrees, and so I get 2 FT sine of 60, and I get F weight down here, and then I get FTX, but those cancel out, so I'm not even really worried about those. So to find FT, I say 2 FT sine of 60 minus the weight is equal to 0 because it's a static situation, and then I have Ft equals the weight, which is 220 newtons, divided by 2 sine of 60. It's 110 over 7. That's equal to 130 newtons. Alright, you have 3 equal masses, each with mass m. You exert a force on one of the masses and get an acceleration a. Now you combine the 3 masses and exert the same force on them. What is the acceleration of the combined mass? So, if I get an acceleration a, if I increase my mass, which is what I'm doing here, I'm increasing my mass by a factor of 3. That means my acceleration drops by a factor of 3. So 24 is a. This guy is pulling an 11 kilogram block along a surface. His coefficient is 0.1. He exerts a force of 40 newtons at an angle of 30 degrees. What is the normal force on the block? So I have the weight, Fw. I have the normal force here, and I want to figure out what is the normal force. Oh, I also know that there is a static or kinetic frictional force here. I'm going to go ahead and resolve this force into its components. I have F sine of 30, and I have F cosine of 30. I know that my y forces add up to equal to 0, so I have F sine of 30 plus Fn minus Fw equals to 0. So Fn then equals Fw minus F sine of 30. That's 110 newtons minus 40 sine 30. That's equal to 90 newtons. Okay, so looking at the last 3 problems here, what is the acceleration of this block? And the surface is frictionless. So if I draw the forces, I have the force weight, I have the normal force, and that's all that I have. There is no frictional force that's holding the block back. Now I want to draw my coordinate system. It's going to look like that. And then recognize that my angle here is not 60 degrees, it's 30 degrees. Now, let's redraw this There's my coordinate system, and I'm going to go ahead and resolve those forces into their x and y components. There's my normal force, and then I have Fw cosine 30 and Fw sine 30. All right, so that's a good, simple free body diagram, or force diagram for my block on an inclined plane. I want to know what is the acceleration. But the acceleration occurs in the positive x direction. I say the sum of the forces in the x direction is equal to max. And it's this value that I want to know. The sum of the forces in the x direction is Fw cosine of 30, and then that's equal to max. So ax is equal to Fw cosine 30 divided by m. And that's equal to, what's m here? Well, actually, this can cancel this. I can make this into an mg, and that gets rid of the m. So it's just going to be a cosine 30, 10 cosine of 30, which is going to be 9 meters per second squared. Turns out, actually, that the acceleration is not dependent upon the mass in this case, when there's no friction. All right. Consider the previous problem. Now the mass of the block is 2 kilograms and the coefficient of kinetic friction is 0.2. What is the acceleration of the block? So now I'm going to add in another force right here, and it's going to be my kinetic friction. I'm going to take this diagram and apply it to the second one. So here I need to find the normal force. So I say the sum of the forces in the y direction is Fn minus Fw sine of 30. And then also the sum of the forces in the x direction is going to be Fw cosine 30 minus Fk. So sum of the forces in the y direction is 0. It's equal to Fn minus mg sine 30. So Fn is equal to mg sine 30 mg, it's 2 kilograms times 10, that's 20 newtons, times sine of 30. So that's equal to 10 newtons. That's my normal force. Then once I know my normal force, I can go ahead and find my kinetic friction. It's going to be mu k times the normal force, 0.2, times 10, that's equal to 2 newtons. Now, I can come back and figure out what is the acceleration. Fw cosine 30, I'll go ahead and put in some numbers here. Fw is 2 times 10, that's 20 newtons, times cosine of 30, minus Fk, which is 2, that's equal to the mass times the acceleration. This is 17 minus 2 equals 2 times the acceleration, so that's 7.15 divided by 2, 7.7 meters per second squared. I had some rounding. Let's see, I'm not sure what happened here, but I have some rounding here along the way. I'll double check that number and just make sure that it works out right. But 27 is D. All right. So in this figure, the block is accelerating down the inclined plane. It does have a force due to kinetic friction. Which of the following equations is correct? Well, I can still use this diagram. It's still the same thing. And so I want to know which equation is correct. So let's look at the first one. Force weight cosine 30 minus Fk is equal to 0. This one is not correct. It would be correct if it said equal to max, because those two forces, since it's accelerating, that sum of forces is not equal to 0. Fn minus Fw sine 30 is equal to max. This would be correct if this said 0 instead of max. And then Fn plus Fw sine 60, no, that's not right. This could be made correct if this were a negative and this were a 30. Then it would be correct, but it's not correct. So B is the right answer for number 28. You might have had a different version of this test, in which case the numerical answers will match up, but not the letter answers.